Today we are going to discuss about one of the intermediate representation 3 address code. In the previous class we have discussed about various intermediate code generation methods. In that first we have seen syntax tree, and next we have seen DAG, directed acyclic graph, and then value number method, how it will be implemented, and we have seen what are the advantages of converting into intermediate representation. Now we will see one of the important intermediate representation is 3 address code. Okay, in 3 address code there is at most one operator on the right side of an instruction. That means the right side should have at least one operand. And also we can define it as it should have maximum 3 operands. Any instruction it should have a maximum 3 operands. For example, here we will take t1 equal to y star z. In the right hand side it is having only one operator, and maximum it is having 3 operands. And more than 3 it is there, means it is not a 3 address instruction. 3 variables should be there. That is, no built up arithmetic expressions are permitted. Built up expressions are not all permitted in the 3 address code. The source language expression x plus y star z. So this is not in a 3 address code, because here we will take 1, 2, 3. 3 operands and 2 operators are there. So it is not a 3 address instruction. So let us will convert into 3 address code. So according to the associativity and precedence rule, which operation should be performed first here? First, that is multiplication operation is performed. So we will store that value in some temporary variable t1 equal to y star z. Then after that, that value will be added with x. So t2 equal to x plus t1. Now both the instructions are in 3 address code, and t1 t2 are the compiler generated temporary names that will be generated by the compiler. And another example is, here we have taken this. For this one, which operation will be the expression within the parenthesis will be evaluated first. So b minus c is performed first. So t1 equal to b minus c, and then next that will be multiplied with a, then a star t1, t2 equal to a star t1, then that will be added with a, then a plus t2, this one, and then t4 equal to t1. In t1 already we found b minus c into t, and then t5 equal to this t3 plus t4. That. So now all the instructions are in 3 address code. Next we will see how the 3 address code is built. So normally the 3 address code is built in from 2 concepts. One is it may addresses, and another one is instructions. So an address can be any one of the following. So here we have seen, here what are the things? These are the temporary names. T1, T2, T3, T4 are temporary names generated by the compiler, and B, C are the variables, and some places we are going to use constants also, values. So that may be the address. So see here, so the address can be any one of the following. It may be a name, or it may be a constant, or compiler generated temporary variables. So the T1, T2 are compiler generated temporary variables. Next we will see list of the common 3 address instruction forms. So what are the different 3 address instruction forms are there? We are going to see now. First one is assignment instructions. Assignment instructions, how it will be: x is equal to y plus z. That is x equal to y. That operator may be anything. It may be a plus or minus or anything. Z. So this is assignment instruction format. Next, assignments of the form x is equal to OPY. That means we can give x is equal to plus y. That is a unary operation. This operator represents unary operation, not binary, because in the right hand side we are having only one operand. Copy instruction of the form will give x is equal to y. Okay, so like that we are having different 3 address instruction. An unconditional jump, then we will give go to L. Conditional jumps of the form, if the condition is true, go to L, else if condition is false, it will go to some other place. Okay, that is the thing. Then conditional jumps such as if relation operator will use if x relation operator y, go to L. Suppose for example, if x greater than 10, go to L. That is a conditional jumps with relational operators. Next is procedure calls and returns are implemented using the following instructions. Suppose we may be having a procedures or subroutines. Then in that, if we are having procedures or subroutines, we will be having function calls and function definition and return type or return first statement, all those things. So how it will be represented means, so we have to represent param x and then call p comma n, which function will be called, and then y equal to call p comma n means this value, the function call p comma n will be called and the values will be assigned to y. So like this we have to make. The next is indexed copy instructions of the form. Suppose we want to assign the value stored in the array to any variable or any variable to array location means we can going to use that indexed method. X is equal to y of I, or for example x is equal to y of 2 and x of I is equal to y. That means one is assigning the value of array to the variable. Another one is the value which is stored in the variable is assigned or stored into the array location. So these are the various 3 address instruction formats. So let us see one example. For example, we will take one, and another thing is, suppose we are using the pointer assignments of the form x is equal to ampersand y equal to star y and star x is equal to y. These are also another 3 address code instructions. Now we will see one of the example. For example, we will take one high level language statement, do while loop. So in that, do I equal to I plus 1 while a of I is less than v. This is a given instruction. So this is not in a 3 address code. Now we will see how this will be converted into 3 address code. So we will take t1 equal to, first which operation will be performed, I plus 1. So t1 equal to I plus 1 while a of I is less than v, that operation. So we will assign I equal to t1, then t2 equal to I star 8. So we have taken that each element takes 8 bytes of memory. So I star 8 and then t3 equal to a of t2. That means this value will be assigned to t3, and if t3 is less than v, what are the thing we have passed over there, then go to L. This v we are given, no? Then go to L, the loop will be continued. So like that, this is for with using the labels. Then this is for using position numbers. Instead of that label, we are using the position numbers. That means location, that is 100. This is position number 1, 1, 2, 3, 4. Then here you can give go to which position it has to go. It goes to go to t1 equal to I plus 1. That is the position number 100. So like this we can represent not only do while statement, it will take any high level language statement, or it may be a if statement or switch case statement, or it may be a while or do while we have used. Other than that, we may be having a for loop. Anything we can convert into 3 address code. So normally the 3 address code only it is used for practical applications. So very important one. And try with other examples also, because once it is converted into 3 address code, then next we will go for a code conversion. Before that, if necessary, we will apply for optimization techniques. So along with this 3 address code methods, we have different representation of 3 address code. Different ways we can represent the 3 address code, that we are going to see in the next class. Thank you.